Hi, my name is Rachel Oken, and I'm going to explain question 5 from Exam 1 from CSE2's 2012 fall semester. This question is focusing on the intricacies of the Java language, the interactions of the different primitive types, operators, and strings. It is really asking a student, do you understand the complexities and properties of the primitive types and strings? Can you take the concepts learned from class in the textbook and figure out what a compiler would do with various inputs? It tests your knowledge of comparing types, casting, order of operations, and concatenation. This type of question covers a lot of small details and asks you to crawl and use this information. Just the amount of rules you have to remember for this question is both intimidating and overwhelming when you are new to programming. To solve these types of problems, you need to be familiar with all of the little rules and properties associated with each type. Once you become comfortable with these rules, solving these types of problems will become very easy. You will just need to be careful of the careless mistakes you can make. When solving these problems myself, I always double check which type of operation is being performed and what type I am dealing with. I also keep notes of the mistakes I have made in the past so that I will not repeat them again. For example, the first time I tried to answer this question, I thought that comparing strings with the equal sign would result in a compiler error. It doesn't. It will, however, not provide an accurate comparison, because it compares where the strings are stored and not the actual characters that make up the strings. It will result in the Boolean false. Before we address the specific answers to each part of this question, I would like to go over the rules that pertain to answering it, and other similar questions that could be asked. I've put together a PowerPoint presentation to quickly cover the main concepts you will need to know to answer this type of question. There are 8 primitive data types. You should be very familiar with all of them by now. One that people have trouble with is char, just because we don't use it very much in the beginning of this course. I'll cover it in more detail in a later slide. You should know that from byte, short, int, and long, those increase in the amount of storage space they have, and float and double are both floating point numbers. Boolean you should know is either true or false. You must declare your variables before you can initialize or assign them, and before you can use them. You can declare and initialize on the same line. Always make sure you declare and initialize before you use them. That's something that he catches a lot of people on. Chars are single characters, and their literals are surrounded in single quotation marks. They're really numbers, and are internally represented as so, specifically as Unicode. You can assign values to a char variable in 3 ways: by having the actual character surrounded by single quotation marks, or have the hexadecimal Unicode value with the prefix \u in single quotation marks, or have the decimal value number of that value here. You could also use the prefix 0x and the hexadecimal number as well. Chars are implicitly casted into integers when they are operated on. I will show this over here. Ch is assigned the variable a. If you add 1 to it, you're implicitly casting the char into a number, and you get the answer 66, because the value of a is 65, so plus 1 gets 66. Same with adding 3, you get 68. Now, if you explicitly cast it back into a char, you get the letter d, which is 3 away from a. Similarly, if you add 3, then subtract 2, which is like adding 1, explicitly cast it back into a char, you're going to get the letter B. A little bit more tricky is if you use the increment or decrement operators. Those will actually change the value of your char variable. So if you use the post increment, you will still get A because it hasn't changed yet, but if you use the pre-increment, it'll be added to beforehand, so you're going to get the letter C because you added 1 here after you printed it out and added 1 here again before you printed out this line. Things will be a little bit different because CH will now have the value C. So if you add 3, you get 70, which corresponds to the letter F, 3 away from C, and if you add only 1, you get D, which is 1 away from C. You can also multiply and divide with chars. If you multiply by 2, the space character, you'll get the number 64, which corresponds to the @ sign. These are different ways you can represent the @ sign. If you divide the capital D character by 2, you'll get 34. This corresponds to a double quotation mark, and these are other ways which you can write the double quotation mark. This is the prefix for a hexadecimal number, if you didn't know. Furthermore, conversions between numbers and chars can be confusing. So we're going to reassign the value capital A to the char ch. You can implicitly convert between numerical and alphabetical literals into the primitive types, except for when you have a floating point. You can't implicitly cast it into a char variable. It has to be explicitly cast. That means char can be assigned with a character, integer number, or Unicode, and all the other numeric types can also be assigned with a character, integer number, and Unicode. The interesting part is that if you have a variable that was a char, that was equal to this literal, you have to explicitly cast it into a byte and short, the rest of the numerical types will accept char stored as a variable as a possible assignment. You can never implicitly cast a numerical variable into a char. It always has to be explicitly done, like it is here. You can see that these all work through these print statements, which are displayed here. Char is equal to a, all the integer type values are 65, floating points are 65.0, and char, using explicit casting, can convert these variables into a letter. String is a reference type, not a primitive type. It is a predefined class in Java, and there are many useful methods that go along with this class that you do not need to know for the first test. What might be useful is the conversions between strings and numbers. You can convert a string into a number using integer parse int or double parse double. More importantly, to cast a number into a string, all you need to do is add that number to the empty set, which will cast it into a string. Also important is the casting rules. We went over that a bit with char, but to reiterate, implicit casting happens automatically when you are increasing the precision or widening a variable. Explicit casting, which you do with parentheses, a data type, and a literal or a variable, happens with decreasing precision when you're narrowing a variable. Numeric literals without decimals can be implicitly casted into a char. However, all numeric variables must be explicitly cast into a char. Char literals can be implicitly cast into all numeric types except for the byte and short type, which have too few bits. The numeric types in order of precision, byte has the least amount of precision and double has the greatest amount of precision. There are the basic numeric types we've known since grade school. Be careful with integer division. If you divide by two integers, you get an integer out. Addition can have two purposes. You can add numbers together. However, if you're adding strings together, it's called concatenation, and that's just pasting the two strings together. If you're adding numbers with strings, the numbers will implicitly be casted into a string. So if you add 3 plus high plus 7, you're going to get 3 high 7, and that will be a string value. However, if you get 3 plus 4 plus high plus 7, you'll be adding 3 and 4 first, so you'll get 7 plus high plus 7, so it's 7 high 7. And then, if you try to do 3 plus high plus 7 plus 3, you're getting 3 plus high, which concatenates to a string, so you have 3 high plus 7, which concatenates to a string, 3 high 7 plus 3, which then concatenates to string. You can't do 3 plus 7 before you do everything else, because you evaluate from left to right. The remainder modulo is not a very hard concept. It's 6th grade math. It just tells you how much is left over if you try to divide by a number. So some examples that are really important to understand. It will only return negative when the dividend, this part right here, the initial number, is negative. It doesn't matter if this number is negative or not. You're not going to get it canceled out. If it divides evenly, it equals 0. And if the number that you're dividing is way too big, the remainder will be whatever the number was. Augmented assignment operators are also really important to be able to use. They shorten code. So if you have num plus equals 3, it's really num equals num plus 3. There's also the increment and decrement operators. You have the pre-increment and decrement operators, which happen before you use the variable, or you have it after you use the variable, which is the post-increment and decrement operators. You have relational operators. These will produce booleans. They will take the two numbers on either side and produce a boolean. You can't have this in a long string of comparisons. Note that equal to is a double equal sign. It can compare like types, or types that can be implicitly cast, or you can explicitly cast the type. Strings cannot be compared with an equal operator. Instead, you have to use this format where stuff1 and stuff2 are both strings, and that will test if it's equal to. There are also logical operators. You have the not, and, or, and exclusive or. Note that there's a lazy and a strict operator, and lazy won't evaluate the second part of it if it only needs to evaluate the first part. It was a very hard question when we had a runtime error on the other side of a lazy operator, and it was not evaluated. You also cannot have a string of comparisons like we have here. This won't work because if you evaluate this part first, you're going to get a boolean, and you can't compare a boolean to a 3. Those are incompatible types. So you have to use the AND operator. It's also really important to understand precedence and associativity. It determines the order in which things are evaluated. All binary operators are left to right associative except for assignment operators. That includes augmented assignment operators. For example, PEMDAS. This is how you would separate it by parentheses. You would first have A and B, then that added to C, and then all of that. And with the assignment operators, it's a little different. You start from the right, so C is equal to 5, and then B is equal to B plus C, which is equal to 5, and B is equal to 1 if it started at 1. So that means B is equal to 6, and then you have A is equal to B, which is equal to 6. This is the chart you get in your book of the order of operations. Be sure to understand this. This is important. This is what screwed me up on my test. You have to evaluate things with ands first. This is a problem you could have in your test to put in parentheses that follows the order of operations used in Java. First, unary operators, multiplication and division, comparison operators, and then you have what I found tricky, the or and the and. You have to evaluate and first, so that means this parentheses goes on first, and then you can evaluate or. I always found that this comes after the and, a little tricky. But once you know it, it's not hard to remember. Some miscellaneous things that I didn't cover, you read on your own. These are all topics that could be covered in your next test and that are important to understand. Now that we've reviewed, you could pause the video to try to answer this question yourself, or you could follow me as I answer each part of the question. To start with, we know that P is initially false and Q is initially true. P is false, and Q is now false because it's negated. So they're both the same, that means it's true, which automatically makes this whole statement true. So the answer to this is true. If you want to evaluate this statement, it would be true and not false, which is true, so that would also be true. Now, is I equal to y? I is a 0, and a y is a 0 double. When you're comparing things, they have to be the same type, so your integer will implicitly cast into a double and compare, which that means they will be the same, so it will be true. Now we need to know if j divided by k is greater than z minus 1, j is 15, k is 7. Since they're both integers, we have integer division, which will get us 2, and z minus 1, z is 3.14, so you get 2.14, which is greater than 2, so the answer here will be false. Now this is very tricky, but we went over char, so you should be able to do this. We have c, which is the char capital D, plus k, which is the integer 7, minus 5, which is in total just a plus 2. So the capital D plus 2 should get you capital F, 2 away from D. We know that you cannot compare strings with the equal sign, so this will automatically evaluate to false, no matter that s plus t would give you the string fall break. You cannot evaluate if t, a string called break, is greater than a string called fall using this type of operation, so this results in a compiler error. Fall plus break, that's concatenated together, and then it concatenates 2 and 1. The result is fall break 21. However, this time, 1 plus 2 is added first, so you get 3, and then you're adding the string s and the string t, which gives you 3 fall break. And this last one, where they're trying to convert the string into a char, this cannot be done, so that results in a compiler error. The skills we covered in this video will be tested indirectly on every programming test you take in this course and beyond. An example of these concepts being incorporated into a different question is the 2014 Fall Exam 2, a test I just recently took about methods. These fundamental concepts will continue to come up in more complex questions. They will be ready to trip you up if you're not careful. To solve these problems, the important thing to keep in mind is that there will always be questions that are designed to trick you. Keep alert and remember the rules. These rules are essential to figuring out when you run it, what any code you come across on test or in other scenarios does. It will also help you write your homework assignments and build a strong base for any future programming you do. All the advice I have heard so far from upperclassmen is take CSE2 very seriously. It'll make the rest of your programming experience in college and beyond that much easier. My name is Rachel Oken, and this is CSE2. Thank you for watching.